Hello everyone, it's Mr. Spinelli, and today I'm going to go through how to factor some basic polynomials. And in general, they are of the form ax² plus bx plus c. They may be of a higher degree, but we'll have some GCFs that'll basically reduce us down to this form. But before we get going, I wanted to do a quick little warm-up, remind you of multiplying two binomials together. So if I multiply this, I'll get 2x squared and plus 3 with something in the middle. Now, I wanted to just focus on why I get this, first of all, because we're going to be looking for some patterns today, because we're going to have to go backwards. So the 2x times the x gave me the 2x squared, and then the 1 times the 3 gave me the 3. Now, there's going to be a middle term to this, and that comes from doing the 2x times the 3, which is 6x, and the 1 times the x, which is x. When I add those two together, I get 7x. So I'm going to want you to recognize these kinds of patterns. So on the next one, I'll go ahead and do those middle terms. The 3x and the times the 5 gives me 15x, and the 2 times the x gives me 2x. So I'm going to have a middle term of 17x. And then on the outside, 3x times the x gives me 3x squared, and 2 times the 5 gives me 10. Okay, so this is going to be a key concept because we're going to have to figure out how in the world we go backwards into what's called factored form. So factored form is this version down here at the bottom. So we're going to have to learn to go backwards. So we're going to do a few examples together. We're going to practice our number sense and really focus on factor pairs to help us figure this out. Now the first step to every single problem is to always factor out the GCF first. So hopefully you watched my other video. Step number 1, find the GCF. If it's 1, you're done and go on to step 2, and that's where you're going to look at some factor pairs. In this case, 2, 5, and 2 are all co-prime, so we say. 2 and 5 have nothing in common. They're both prime numbers. So now I need to think of the factor pairs of 2, and I know this seems silly, so I'm going to think of the factor pairs of 2, which are just 1 and 2, and I need to think of the factor pairs of 2. Okay, in this case, they're both the same, 1 and 2. Now, I'm typically always going to focus on A and C because I know what my first part of my factored form will be. I know that to make this 2 right here, I have to have a 2x and an x. That's the only way I can multiply to make 2x squared. I've got to split the x squared up into an x and an x. Notice that pattern in both of these two problems. So I've got to have a similar thing going on here. And now the only way to multiply to make this 2 is to have a 1 and a 2, because that's the factor pair. So I'm either going to have a 1 here and a 2 here, or a 2 here and a 1 there. Now the other question is, am I going to add these numbers or subtract them? Well, today I am strictly going to focus on problems where we're adding the middle term, which means these will always be positive. Now, how do I know which one goes there? The 1 and the 2, 1 or the 2 on this first factor? Well, it can't be the 2, because if it were the 2, let me just write out what that would look like. I would have 2x plus 2 in this parentheses. But these two terms have a GCF of 2, which means I could have pulled a 2 out at the very beginning. But that wasn't the case. In this particular problem, my GCF is 1. So I know it has to be 1 and 2. Now let's verify if that is actually correct. All I need to do is check the middle terms. The middle terms need to multiply and then add together to make 5x. 2x times 2 is 4x, and 1 times x is x. 4x plus x gives me my middle term, 5x, which is exactly what I wanted. So hopefully you're a little confused, or hopefully this made perfect sense. Either way, let's try another. X squared plus 7x plus 10. Alright, remember, these are all in the form ax squared plus bx plus c, save for a GCF. So in this problem, my a is 1. So I know that this is going to be x plus something and x plus something in factored form. Then all I have to look at are the factor pairs of 10. Well, that's 1 and 10 or 2 and 5. Now this is one of the easier ones. Whenever your a value is 1, all you have to do is find the factor pair that adds up to your middle term in this case, since we have a positive 7x. Well, that's 2 and 5. So I know this is x plus 2 and x plus 5. And I know someone's going to ask, can I write x plus 5, x plus 2? And I'm going to ask you, what's 2 times 3? 6. What's 3 times 2? 6. Multiplication is a commutative process, which means you can do it in any order you want. So either of these is correct. Let's try another. Alright, this one is much more fun. First thing I want to do, which I didn't technically say on the last one because I had a coefficient of 1, which meant my GCF was 1. So step 1 is always to find the GCF. Well, 6, 28, and 16 are all divisible by 2. So I'm going to first have to factor out 2. So when I factor out 2, what am I left with? Well, I'm going to do that in a different color. I get 3x squared plus 14x plus 8. So what I have written in green is now my new problem to actually factor. And I'm going to factor it as I did the last few problems. So it's going to be 2 times something. And that something, I'm going to look at the factors. The factors of 3, which are simply 1 and 3. So I know this is going to be a 3x and an x. And then I've got to look at the factors of 8. Well, this is where it gets a little more involved. So 1 and 8 and 2 and 4. So now I've got several options to consider. I know these are both going to add because I have to add to make positive 14. That's my goal. So then I can either have the 1 here and the 8 here, or the 8 and 1 here, the 2 and 4, or the 4 and 2. So there's 4 combinations that I have to consider. And what I need to look at is when I multiply the 3 by these numbers, or when I look at the 1x times these numbers. Okay, but I'm really focusing on the 1, not as much the x. And then I add those two results together. So purple times purple plus green times green needs to give me that 14 that I'm looking for. So if I were to do that, let's look at this first one. 3 times 8 is 24. So that is way bigger than 14. So I already know that one's wrong. 3 times 1 gives me 3, plus 8 gives me 11. 11 is not 14. That one's wrong. 3 times 4 gives me 12, plus 2 gives me 14. So this is my winner. And if I look at the last one, 3 times 2 is 6, plus 4 is 10, so that one is also wrong. So this is my factored form. I would write 2 times 3x plus 2 times x plus 4. Alright, let's take a look at another. Alright, in this one, I got to start, as always, with my GCF, which I should always do. What goes into 4, 22, and 24? Well, those are all even numbers, and 2 goes in. And then I notice that all of them have at least one x, so I can factor out a 2x. So I'm going to factor out a 2x and see what I'm left with, and that will be my new trinomial to factor. So I've got 2x cubed plus 11x plus 12. Alright, so I am going to focus on the factors of 2, which are nice. There's only one factor pair. And then the factors of 12. Alright, well, there's a few here. I've got 1 and 12, 2 and 6, and 3 and 4. So again, this GCF, I probably didn't mention it enough, is always going to just tag along. Because if I factor it out, it's got to come along with, because when I multiply all this out, it's got to give me the same result. So because the factors of 2 were 1 and 2, I know I'm going to have a 2x and an x, 2x and 1x. But now, I could have 1 and 12, 12, 1, 2, 6, 6, 2, 3, 4, 4, and 3. All 6 of these combinations are possible, but let's talk about why I shouldn't even waste my time considering some of them. Remember, I said the GCF was 2x. That means if I were to put this 12 inside the parentheses with the 2, those are both even numbers, which means the GCF should have been bigger than 2x, which isn't the case. So I'm not going to consider this one. The one below it, the 2 is in common with this 2, so I could have pulled out more from the GCF. So I don't consider that one. 6 is even, don't consider that one, and 4 is even, so I don't consider that one. So of those 6 combinations, I only have to consider these 2. So please think about your number sense and how you can really reduce the size of the problem, because many teachers or people or friends are going to tell you that factoring is all about guessing and checking and guessing and checking. And that's not entirely false, but you can really reduce how much you're guessing and checking by using your number sense. So now, if I were to multiply the 2x times these numbers, and if I were to multiply the x by these numbers, and then add those results together, I need to try to make a positive 11x. So remember, these are all going to be positive, which makes my life easy. So 2x times 12 gives me 24x. That one's way too big. So I know that one's wrong, and I know my answer is 3 and 4. So that is how easy this can be if you use your common sense, use your knowledge of GCF, and just multiply numbers together and see if they're way too big or way too small to even consider. So this would be my factoring of that result. Let's try another one. All right, this one is great. There are nothing exciting about step number 1, which is finding our GCF. Our GCF is 1, so I'm not going to factor out a 1 because it doesn't change anything. Now I'm going to look at the factors of 5. Well, there's only one factor pair. It's 1 and 5. But the factors of 24 are a little more extensive. I've got 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So I've got 5x and x using my factor pairs of 5. And I know this is going to be a plus because I'm trying to make a positive 34x in the middle. So it can be any of these 4 factor pairs in either way, because the 1x and the 5x, those coefficients 1 and 5 are prime. So they're going to have nothing in common with these numbers here, because 1 and 5 don't appear. And if 1 does, it doesn't matter, because a GCF of 1 really doesn't mean much for us. So I could have the 1, the 24, or the 24 and the 1. So I've got a total of 8 combinations to consider. But we'll notice that some of these numbers just are too large. So 5 times 24, big number. 24, so again, I'm multiplying, let me change the colors that I'm doing. I'm multiplying the 5x by all of these numbers, and I'm multiplying the x by all of these numbers. So that's what I'm saying as I go through my head. So 5 times 1 plus 24 only gives me 29x, so that's not big enough. The one above it was way too big. 5 times 12 gives me 60, so this is more than 60x. 5x times 2 gives me 10x, plus 12 times x gives me, so 10 plus 12 gives me 22x, that's not 34. 5 times 8 is 40, that's too big. 5 times 3 is 15, plus 8 is only 23, not quite enough. 5 times 6 is 30, plus 4, there's my winner. So my factorization of this problem gives me 5x plus 4, x plus 6. Again, always do a quick check. You don't need to do the 5x times the 6 or the 4 times the 6. Sorry, the 5x times the x, because you know that gives you the 5x squared, and you know the 4 times the 6 gives you 24 because you looked at your factor pairs, which is why you did that. Okay? Alright, last one. 4x squared plus 27x plus 18. The GCF on this problem is 1, so I'm just going to start with my factor pairs. 1 and 4. That got messy. 2 and 2. And then for 18, I've got 1 and 18, 2 and 9, and 3 and 6. So I've got two different scenarios to consider. With this first one, I can have a 4x and a 1x. And with the next scenario, 2 and 2, I would have 2x and 2x. So I'm going to tell you why I'm not even going to waste my time with the 2x and the 2x. 18 is even, so that couldn't go in either of these two parentheses because it would have a GCF of 2 then. 2 is even, another same reason won't work. 6 is even, so that won't work. So I don't even have to waste my time considering these options. So now I can do 1 and 18, but can I do 18 and 1? No, because 18 and 4 have a GCF of 2. So I can factor out a 2 from those. So I'm not even going to consider that one. Same reason I'm not going to put the 2 over here. I'm going to put the 9 and the 2 and the 3 and the 6. So what would have been 12 combinations, I really only have 3 combinations because of my number sense. And some of you will have to do all 12 combinations to just check them. Some of you are going to be able to figure out these 3 right away. Now again, my goal is to make a 27x, and in order to do that, I am multiplying the 4x times the 18, 2, and 6, and then I'm doing the x times the 1, 9, and 3. Well, the 4 times the 18 is too big. I'm not even going to waste my time multiplying it because it's bigger than 27. 4 times 2 is 8 plus 9, not big enough. 4 times 6 is 24 plus 3 is 27. That's my winner. So the 3 goes here and the 6 goes here. I hope you enjoyed. Please stay tuned for an ax² minus bx plus c video. Thanks and have a great day.